Hello, my name is Laik Nurhan. I'm an undergraduate research assistant at Institute of Smart Systems and Artificial Intelligence. This is the second part of the tutorials on speech command recognition. In the last tutorial, we talked about the TTS-generated dataset. In this video, we will consider scraping the Kazakh Speech Corpus 2 dataset. The Kazakh Speech Corpus 2 represents the premier open-source speech corpus for the Kazakh language. KSC2 contains data collected from diverse sources such as TV shows, radio broadcasts, Senate sessions, and podcasts. KSC2 encompasses roughly more than 1,000 hours of high-quality transcribed content, corresponding to over 520,000 utterances with 16 kHz frequency. We scraped KSC2 dataset to identify transcriptions containing at least one comment of interest. In order to automatically trim the identified comments from the utterances, we utilize the VOSG speech recognition model. VOSG has several advantages such as rapid inference on a central processing unit, provision of starting and ending timestamps for recognized words, offline functionality, and compatibility with the Kazakh language. Now you can see the KSC2 speech comment scraping algorithm. Each transcription in the KSC2 was examined to ascertain if it contained any comment of interest. If at least one of the comments was detected, the corresponding utterance was processed using the VOSG speech recognition model to recognize the comment and the respective timestamps within the utterance. Subsequently, the detected comments were trimmed using the timestamps and saved in a WAV format with a 16 kHz sampling rate. Let's look at the bar plot. As you can see, the number of samples for some classes are quite low. In total, more than 200,000 samples were extracted for 35 comments. However, the dataset exhibited a considerable degree of imbalance among the comments, as you noticed from the last slide. In order to make its size the same as synthetic TTS dataset, comments with more than 2,430 samples were randomly downsampled, while the others were undersampled, utilizing the augmentation techniques employed for the synthetic TTS generation. And about the augmentation techniques, we will talk in the next tutorial. So in total, the processed KSC2 dataset contains 81,365 samples. So now, let's move to the coding. For this tutorial, we'll work with speech corpus scraping file. First, we need to install the VOSG. Then, import the required packages. After that, we are defining the CMD counter dictionary, where key is a comment and value is the number of detected and trimmed comments. You can also modify it with a custom list of comments. In this tutorial, we will consider two examples. They are located at speech corpus folder. And in this line, we are creating a new directory. Let's check the number of WAV files and TXT files. As you can see, it's 2. And now, let's place the example WAV files and see their respective texts.
Alға қарай 5 метр жүр, тоқта. Сосын солға қарай 2 метр жүр.
For the first example, the words that we want to extract are alға, артқа, 5, жүр, тоқта, солға, 2.
Жарықты қос, жазбаны оқы.
And for the second example, the words that we want to extract are қос and оқы. And here is the main part. We are loading the VOSG speech recognizer model for Kazakh language. To do so, we need to follow this link, download and unzip the VOSG model. The sampling rate is 16,000 and confidence threshold is 0.5. The code snippet Kaldi recognizer model SR creates an instance of the Kaldi recognizer class from the VOSG toolkit. In the given code, the rec.setWordsTrue method is called to enable word level recognition. This means that the recognizer will output recognized words along with their timestamps and confidence scores. Enabling word level recognition basically allows you to obtain more detailed results from the speech recognition process. Next, we are looping through WAV path and TXT path, also verifying the correspondence of file names. Then splitting the lines into word in TXT file. Next, we are recognizing speech using the VOSG model. The accept waveform accepts audio samples as input and performs the recognition process. And also, we need to load the original WAV file via audio segment for segmentation. Finally, we are looping through VOSG results and getting the sentences. You can also output sentence to understand how it looks like. Basically, sentence here represented as a dictionary, where it has two keys, result and text. If there is a result, then it will contain a confidence score, starting and ending time, and the word itself. So therefore, we're looping through sentence result and checking the conditions. If the conditions are satisfied using the starting and ending time, we're trimming the audio, then saving the audio in the respective directory and updating the number of detected and trimmed commands. So let's play the extracted commands.
Бес жүр. Тоқта. Солға 2 жүр.
оқы.
We can also convert the dictionary to pandas data frame for further analysis. So that's it. In the next tutorial, we will talk about the augmentation techniques. Thank you for watching.